Na tusome, as I said, kuna prota structure. Prota structure is here. Kuna robot structural analysis, as you can see. Kuna robot. Kuna Tekla structural designer. Tekla is actually good. Inakuonyesha calculations, then at the same time inakuonyesha the structural details. Kuna Midas. Midas nimejoin juzi, nimejiunga nao juzi na wamenilink, tunafanya kazi pamoja nao. Nafanya kazi na Midas Gen. Then kuna ETABS, a very comprehensive and very important software. ETABS, it's just an acronym. In full, it's called Extended Three-Dimensional Analysis of Building Systems. The current version is version 21. Then apart from these softwares, as I said, kuna AutoCAD. AutoCAD is just a complete software that can help us do the detailing of of anything that we want. Kama ni structures, kama ni beams, kama anything. So long as you want to do the detailing, you want to present your details, the structural details to your client or to your supervisor or so, then AutoCAD is a very important software. Kama haujajua kutumia AutoCAD vizuri, you can just request me to have a session with you guys. You can learn AutoCAD in 2 days. Siku mbili hivi utakuwa umeanza kusoma AutoCAD. Then now kuna advanced still. Advanced still, it's not an analysis or a design software. Hii inatumika ku detail. It's just a detailing software or detailing of the steel members. Then AutoCAD, I think hii wengi wenu mmeipitia, mnaielewa vizuri. Hii ni for architects, lakini ni vizuri uielewe pia kwa sababu unaweza pata side hustle ya architectural works. Mtu anaweza hitaji kuchorewa nyumba, so you can just do it with AutoCAD. The latest version is 27. Then now, as I said, in water, you cannot avoid Civil 3D. In roads, you cannot avoid Civil 3D. Hii itatumika sana remember in Civil 3D, we always talk of the horizontal and the vertical alignments. So those alignments and the profiles, tunatumia Civil 3D kuzichora. So remember that. So if you want a session with me to learn these softwares, I'm totally available. It's just for us to arrange a class with us, then we can easily learn all these softwares. But as I said, si lazima ujue softwares zote ndio ukuwe a complete civil and structural engineer. Ukishajua, remember, to be a complete civil engineer, lazima ujue Civil 3D. Hii hapa uwezo ka avoid because kuna culverts, kuna barabara, kuna maji, the pipe work, kuchora hizo pipe network venye una distribute maji from, for example, dam. If you want to be a dam engineer, you cannot avoid Civil 3D. And if you want also to be a dam engineer, remember Civil 3D will just do the civil works. But now, to ensure the stability of that dam, you have to perform the analysis and design. So to perform the analysis and design, you actually need some softwares like Midas Gen, we have robot, we have prota structure. So all these softwares will do that. Lakini at the moment lazima ujue manual calculation, kwa sababu hiyo manual itakusaidia aje? The manual calculation itakusaidia at least
naona inazingua, imepotea kabisa.
through prota, then prota will send a file that can be opened by ETABS, then hiyo kazi inaweza fanywa completely. Huyu mtu anatumia huyu but now through Revit. So that is the linking between prota and ETABS is through Revit. So that's why tunasema Revit Sabim software. Then you can also send ETABS to robot through Revit, or ETABS to Tekla structural designer through Revit. That's why now Revit is like the sender of all these softwares. Now, for still design, as I said, we always just do the checks. You pick the member, you expose that member to loads, then you perform the checks. So we have ProtaStill. ProtaStill is a very important software that can perform the checks and do the detailing of all the members. Kutumia bolts ama kutumia the weld ones. So ukishajua prota structure, it will be so easy for you to understand ProtaStill, because this one will just do modeling, then ProtaStill itakusaidia sasa kugenerate drawings. Hizo drawings utajizileta sasa kwa AutoCAD for printing purposes. Now, with this Excel, I just opened the Excel. Let me, I don't know what's this. Now, this is the, venye tunajua sisi wote, I think Kenya, Tanzania, let me say East Africa, wote tunatumia BS 110 for concrete design. But now we are trying to shift from BS to Eurocodes. Now with this Excel, it's a complete, I can say it's a complete software that can help you learn BS 110 and Eurocode at the same time. Now in BS or in structural analysis, to perform the structural analysis, I'll just show you. Okay. Assuming that this one is our building, naenda kuchora a 2D building hapa. Assuming that this one is our building, so hizi ni columns. Indakana ujue how loads move from one element to another. So assume that this one is the floors. Ukichukua ya kwamba this one is the floors, this one is 3 meters, 3 meters, 3 meters, and then this one is ground level, also 3 meters. Then is 3 meters is in heights. So indakana ujue how loads are transferred from one element to another. Na hivyo ndio sasa tutaenda kudesign our structure. Pia tukiasumi ya kwamba hii building yetu iko na roof, si roof slab, because tuko na roof na roof slab. So tukiasumi ya kwamba hii ni roof yetu, something like this, lazima ujue how to design this roof. So for this roof, inaweza kuwa ni steel structure, or inaweza kuwa timber. So lazima ujue how to design the timber truss, na pia ujue how to design the steel. To design this, it's very simple. You can just use prota structure and it can give you all the structural details. Ni kuiweka tu, unaweka the spans, unaweka the members, then you perform the checks. Kama members zote zitapita the design checks, then you just send it to ProtaStill, then you produce your details. Otherwise, pia tunaweza kuwa na a structure without the roof, without this roof. So tunakuwa tu na the roof slab. The top slab inatumika kama roof. So hizo vitu zote ndakana tuzingatie, tujue ya kwamba hivi ndo tunaenda kuzifanya. So I'll just delete this. So now assuming that this is the structure with the roof slab, now how are our loads going to be transferred to up to zifika huku chini kwa foundation? So utapata if this one is your slab, of course ni kitu kama hii tukiassume ya kwamba hii ni plan. Sasa tukiassume ya kwamba hii ni plan yetu, then hii ni slab panel, hii ni another panel, this one is another panel like that. Then tukichukua section utapata this column is this one, this part is one, then this one is this one. Hapa hivi itakuwa linked to this. Then hapa this one, acha tu assume kwamba tuko na flow hapa column somewhere here. Then the last one, this one link na hii. So for this cross design structure, the lazima tujue how loads are transferred from one element to another. Then tukishajua how they are transferred from one element to another, then another thing, how do we design now these elements? So kufanya tu ili, kwa sababu tuko na muda mchache, ndawaeleza tu haraka haraka. Now kitu cha kwanza tunaanza na kudesign slab. So tunaanza na kudesign slab, na ujue tuko na different types of slabs. Kuna solid slabs, kuna ribbed slabs na kuna waffle slabs, na pia kuna structures zenye huwa tunaweka tu flat slab. So ni lazima ujue how to design all this, but mostly in BSETA 110 itatufunza how to design two types of slabs. Kuna solid slab na ribbed slab. So hizo zote Excel iko na hizo vitu zote, you should not worry about that. If I for example select Eurocode, I'll just pick Eurocode to do the example. So kama unafanya solid slab, then I'm going to explain all this hapa hivi. But now what if you are doing the ribbed slab? For the ribbed slab utapata imekupatia all the calculation and some details about that ribbed slab. All these details are obtained from, this one is for Eurocode. So utakuja hapa hivi inakupatia the clauses penye information unaipata, all this, the clauses, the tables and everything, and all the calculations. Then apart from this, now all these calculations unaweza zipitia, then ukikuwa peke yako you can understand all of them. Then at the end of the day you can now print this one as the output file. Then for the solid slab, because we are conversant with BSETA 110, let me just go to BS. Kitu cha kwanza ni material ambayo unatumia. Hii material, the density of concrete for example, hii density of concrete tunaitoa wapi? Now, before tuende huko, acha niwaeleze how the loads are transferred. So, slab itakuja ipatie load yake beam. So, because hizi ndio beam zetu, these ones, hizi ni beams. Then hii ni slab. So, slab italeta load yake kwa beam, like this. Hii slab italeta kwa hii beam, then some itaenda kwa hii beam. Kuna venye distribute the loads, I will tell you that. So tukisha distribute the loads to the beam, then beams inaleta loads zake sasa kwa columns. Na ujue juu ya beam kuna walls, so lazima uweke pia loads za walls zikuje kwa beams, then you will now use that one ulete loads kwa column. So itakuja like this. Acha nitumie color tofauti, can use this one. So beam italeta sasa load yake kwa column, hii beam italeta kwa hii column, then this beam italeta kwa hii column, then this one italeta kwa hii column, like that up to that. Then cumulatively column italeta loads zake kwa foundation. So tunajaribu kumaanisha nini? Ukisha design slab utapata load ambazo zitakuja kwa beams, then you will design the beams. Design beam. After you design your beams, then you will have to design the columns, because sasa beam imeshapea column loads. After you design the columns, then all the loads will now be transferred to the foundation. So at this point you design your foundations. So for the foundations, remember we have different types of foundation. Kuna strip, kuna pad ama hiyo single mnaijua. Then apart from that kuna combined, then kuna raft foundation, hizo zote. So indakana tujue hizo. Apart from that kuna pia now the piles. Indakana tujue how to design the piles. And remember now, apart from this software zenye tumewaonesha, nimekumbuka kitu hapa venye nimetaja piles, nikakumbuka prokon. So prokon is also among the best softwares, especially in pile design. Ama pia zinaitwa caissons, pia kuna zenye zinaitwa caissons. Uende muangalie hizo piles or caissons. They are different, but I'll just use them as they are like that. So for the columns, we also have the piers. Kama is a could design bridge. Remember tuko na bridge design. So for the bridge design, apart from ETABS, kuna another software inaitwa CSI Bridge. We can use that one to design the bridge, or we can use Autodesk Bridge. Kuna softwares mingi. So ni wewe tu ujiulize unataka kutumia nini, na ukisha concentrate kwa hiyo focus on it, na uielewe vizuri, kwa sababu project ya bridge ikitokea, remember most of the bridge these are government sponsored projects, so ni lazima ukuwe umeiva, if I can use the term, ukuwe umeishika vizuri, so that ukienda kuifanya hakuna kujidoubt. So slab itapea beam load, beam ipatie column, foundation, then after foundation then tuna design piles. Kama foundation, kama tutahitaji kufanya piles, then uta design piles. Now sijataja kitu kimoja hapa hivi, kuna staircase. Staircase huwa ina designiwa kando, huwa tuna design peke yake. You design staircase as an individual element, una design tu kando peke yake. So this one haiko included as part of the structure, lakini ni lazima uidesign. So when you come to this Excel, ni venye tu nimewatajia, I want us to look at it. First of all, uta design your slab, then it's not all about designing. After ume design, lazima uoneshane, because hata mimi penye niko, ninapofanya design yangu, ninapochora the details in AutoCAD, ni lazima nioneshane the calculations ya kwamba hivi ndio nilifanya, hizi ndio load zenye nilitumia na calculation yangu imepita. So as you can see, you cannot present this Excel as you can see it like this. Hii ni ngumu sana mtu wa kawaida kuelewa, hata wewe nikikutumia saa hizi itakuwa ni ngumu kidogo. Lakini now, how do I present all these calculations for any other engineer apart from people who understand this Excel? For any other person to understand my calculation, how do I present it? So to do that, after umefanya all this zimepita the design checks, utakuja hapa hivi, then we can now discuss this. So hapa hivi utaweka your details as you can see, then all this penye calculations zimetolewa kwa BS 110, unakuja hapa hivi una quote, then ukienda hapa hivi kama ni cover ya slab, unaenda kwa hizi two tables, table 3.2 and 3.4, then itakuonyesha how you obtained your cover, and any other person can understand, because this is the standard way of presenting your calculation as an engineer. Penye umetoa loads, ukuja uoneshane penye umetoa loads. Kuna BS 399 part 1 table 1, this one will give you the live loads or the embossed loads, then you perform all this to get the loads. After that, now you perform the structural analysis. To perform analysis is just to get the moment, the bending moment and the shear forces. After umepata your bending moment, as you can see, we have now our bending moments, slab moments. Now you perform the design. To perform the design is like you are now converting the moments into getting the reinforcements. So hizo reinforcement ndio tutatumia sasa kudetail our slab for us to get now the structural detail that can be submitted to the clients or to your senior. So to perform the structural design, BS imetupatia the procedure. You just go, kama ni BS 110 part 1, you go to this clause 3.444, then itakupatia formulas zote. These formulas zote ziko incorporated to this Excel. Then at the end of the day itakwambia kwamba tumia T10 at 250 and the error provided is 314. So that is it. Zote unaenda hivi up to hadi huku chini. Then after that, now itakuonyesha pia venye imefanya the checks, how to get the minimum area of reinforcement, how to get the maximum area of reinforcement, how to check for the spacing of the reinforcement kama zimemeet, all this. So at the end of the day utakuja ugundua ya kwamba hii it's a very comprehensive, imecover all the details zenye zilikuwa zinahitajika kupeanwa without kuchoka. It's just for you to input some to include some inputs hapa hivi, then at the end of the day umemaliza. For beam, now for beam design, najua ya kwamba as I was talking to Innocent, aliniambia mko TAD at the moment. I don't know if it's true, but if that's the information, then I will just request you to learn moment distribution method. Kuna methods mingi, kuna moment distribution method, kuna moment theorem, kuna Kilasperian. Hizo method zote zenye mmesoma ama mmefunzwa kufanya moment, kutafuta moment na shear forces, make sure you go through them, but ubaki na hii moment MDM, moment distribution method. Hii ndio ukienda softwares zote, hiyo prota structure, Midas, robot, ETABS, all those softwares zinatumia moment distribution method. Forget about the Clasperian three moment theorem na hizo zingine, sijui area method, forget about that. Learn moment distribution method and have it. Kwa sababu gani nawaambia hivyo? After learning, I applied the method, and when you come to this Excel, ni wewe tu ukitaka kudesign your beam, you enter your spans, you enter some details hapa hivi ambazo tutadiscuss with those who will be available for the sessions. Then after umeweka all this, the loads will be calculated. Then when you come to this tab, as at now inakwambia don't show calculations, but if I click show calculations, if I change to show calculations, so you will now see imekupatia the S moment. This one is span moments. What does this one mean? So hapa kuna at risk span beam. Let me just draw this beam tuelewane, muone kitu najaribu kumaanisha. I will pan this. So if I pick this one as my beam, if I pick this one as my 3-span beam, so he's in columns, pinned supports. Remember, we always pin the beams to reduce the moments, or to reduce the moments at the supports at the columns. So assuming that this is our bending moment diagram, even the bending moment diagram here to here, then I'll just pick another pen, a yellow one like this. Okay, hii ni kama hamtaona vizuri, sorry. Okay. So, tukiassume ya kwamba hii ni bending moment diagram yetu, tuko na 3 spans. So, for these 3 spans, tukikuja kutafuta moments, this one is 4.2, 5.6, then 3.7. So, this span is 4.2, this one is 5.6, then this one is 3.7. Msijali natumia mouse kuandika, so this one is 3.7 meters and this one is 5.6. So if these ones are our spans, through moment distribution method, this method inatakana tupate moments, and these moments, as you can see, Excel ishakufanya. As for the first span, this one is 53.9. So the moment at this point, this moment, this one is 53. This one is 53.7. Then the second moment, I'll just push this one here, 69.25. This one is 69.25. Then for the third moment, 37.67. Apart from that, lazima tupeane pia the support moments. So the first moment, for the first support moment in huwa 0, the first and the last support, ukitumia moment distribution method, even the 3 moment theorem, first moment and the last moment, you fix them so that this moment and this moment is equal to 0. But for the second and the third supports, as you can see, second and third, the moment for this one is 107. This one is 107.79. These are the moments. Then hapa hivi kuna 96.4. 96.4. Now, this one is moment distribution method yenye nimeincorporate na inakupatia the exact values, because as I said, this is the workbook that we are actually using kwenye nafanya kazi. Ndio tunatumia kufanya the structural details, then tunapata the economical design. So this is the bending moment. For Excel sijaonesha, but venye nimechora, I think now you can understand. For the span moments, this is the span moments. Now, as I said, hii inafanya up to 15 spans. If I put the 15 here, utaweka the spans, then all this information, the other information I'll discuss with you. Then for the span moments zimekuwa calculated and so on. Let me just use 4 spans. Now, after umepata your moments, of course, now hiyo ni kama umefanya the structural analysis. Now you have to do the design. To do the design, ni hizi calculations zenye mnaona hapa, uje upate the areas. So after getting your areas, you'll have to get now the reinforcements. So for this reinforcement, it's just a matter of selecting to avoid this red color. So for the first span, as you can see, you can just use 2T16. We don't need this. So 2T16 is enough for this. Then for the second span, 2T16 haifanyi, imefail. So we can use 3T16. Hapo iko sawa. Then for the third span we can use 2T12, inafanya kazi, as you can see imepita. For the last span, the fourth span, 2T16 haiwezi, we can go for 3T16, iko sawa. Then unakuja sasa kwa support moments. Hapo kwa support, now what are the reinforcement for this support moment? As you can see, just put this one 0. So 2T16 haiwezi, 2T20, let's try 2T20. Pia haiwezi, we will go for 3T20, ndio itapita. Then here we can use 2T20. Details, nita explain how to now convert this reinforcement to details kwa AutoCAD. Hizo zote ndawaonyesha, and I'm also working out on how to automate, like you just click, then these details zinatuma kwa AutoCAD na generate reinforcements zenyewe peke yake. For this one we can use 2T20. Hiyo mwisho tunaweza tumia 2T20, I think it will work like that. So after that utakuja kugundua sasa tumemaliza mambo na kudesign slab. Now remember, I think we will discuss all this, the different types of slabs. By default, tunajua tuko na 2 types of slabs, but tuko na 3 types of slabs. Kuna T, kuna L, na rectangular, the R-beam. I will discuss all of this. Then, apart from designing, you have to perform the checks to make sure that everything imepita. As you can see right now, even without doing anything, imekwambia deflection is checked and it is satisfactory. For cracking of the concrete, inakwambia cracking control is checked and it's also satisfactory. So, hizi kufikia hapo hivyo tushafanya the checks, and also this first tab, this one is used for design of the shear links or shear reinforcements or the stirrups kama mnaweza ziita hivyo. So for this one, as you can see, we can use T8 at 250 or 225, but at least tukatumia at 275 or 300 because hii imesha fail. So we can use that, or otherwise we can go for T10 and so on. After umefanya the design of the beams, because tushamaliza slab, tushamaliza beams, so it is time to perform the design of the columns. So for this building, let me use this color. Kuna column hapa, kuna column hapa, kuna column hapa. So this is just the assumption, but this column to from the architectural plan. So kuna columns hapa hivi, these are the columns. So as an engineer lazima ujue the size of these columns. Hauwezi ukasema tu acha ni kama with a column of, for example, 200 by 200, because at the end of the day they will fail. So ni lazima ufanye sizing of the column ndio kama na the right size yenye utapea client ajenge. So how do you do the sizing of the column? Kwa hii Excel nime include that. After umefanya the beam design and the checks, the next tab ni kufanya column sizing. For column sizing hapa hivi ni lazima ujue uko na floors ngapi. So if I pick this one, if I pick this as our building, hapa kuna ground floor, kuna first, kuna second, then this is the roof slab. We can just call this one as roof slab, like that. So this one is the roof slab. But otherwise tuko na columns ngapi za kudesign? Kuna ya kwanza hapa, kuna ya pili, kuna ya tatu, ya nne. So this Excel will just request you to enter the number of columns that you're supposed to design. Kuna the first one, kuna the second, kuna the third, then kuna fourth column. So when you come to this Excel, you just put here the number of columns. I'll enter 4 columns like that. Then, as you can see, kuna hii column, let me just have 2 screens like that. As you can see, kuna hii column yenye natoka ground level, because as this is the ground, we'll just assume that this is now the ground level. So kutoka kwa ground up to the first floor level, kutoka hapa kwa ground up to the first floor, hapa imekuambia hivyo. As you can see, kuna ground to first, then kuna first floor to second floor, kuna first to second, this one, first floor to second, hapa hivi. Acha nichore hivi ndio tuone. Kuna hii column yenye inatoka ground to first, then kuna first to second, then kuna hii ya second to third floor, then kuna hii yenye inatoka third floor to roof. As you can see now, kuna ground to first, this one, first to second, this arrow, then kuna second to third, this one, then kuna third to roof slab. Imesema roof slab kwa sababu mwanzo tukikuja kwa home tab hapa hivi lazima uselect kama unaiambia your structure, the structure tab, kama ni structure with a roof. Hii yenye kuna roof inamaanisha utaenda design the roof truss either timber ama steel. So hiyo inamaanisha kindly sit down na ujifunze how to do that. Kama haupati mwelekeo mzuri, you can just reach out to me, then I will give you the documents zenye zinaweza kusaidia kufanya hiyo haraka haraka, na pia ikufunza how to do that. Otherwise ujifunze how to design the roof slab. Kama unajua kudesign roof, then kudesign roof slab is just the same procedure. So after umefanya hivyo, you'll enter all these parameters, then at the end of the day itakuja kupatia the output size of the column. Kama hapa hivi imetuambia 200 by 350 imefail, inatuambia increase the column size. So we can just increase this one to, let's say, 450. You can use 200 by 450, imefail bado. So for this one we can go with 550. Then as you can see the column size is satisfactory, kumaanisha imepita. So ukikuja nayo unaanza kufanya unaziweka kwa plani venye ziko. Ukishafanya hivyo then ushafanya column sizing. So unakuja column design, na hii column design according to BSETA 110 hivi ndio column design ufanywa. It's very simple, easy and direct, like very simple. If we get time I'll explain to you all this. Na ni rahisi tafadhali, hiyo siwezi kuwadanganya, ni rahisi sana. Ni kutafuta tu the load. Remember ku design the column, this is how we always design the column. If we assume that this one is our column, ukiassume ya kwamba this one is our column huwa inakuwa na the axial load denoted by PU. This axial load ni hiyo compression force. Na hii force inatoka wapi? Ni hiyo force yenyewe inatoka kwa walls, column yenyewe, beams na slabs. So utapata kama beam imekaa juu ya column like this one, hii beam inaleta load yake like this. And that's why when you do the, I don't know if I have any file, let me just show you. Also if you want to learn the structural design, unaweza kuja kwa Chrome, then search for this online platform inaitwa Strian. This one, the Strian structural analysis, this one. So ukichukua hii utafinya, utabonyeza hii ya kwanza, the Strian free online structural analysis. Ukishabonyeza hiyo itakufungulia. Now hapa hivi utaenda, you'll have to enter the data. So acha ni assume kuna kabeam kamoja, assembly supported beam, haraka tu kwa sababu nataka niwaoneshe, ndio niwaoneshe point ya haraka. Nda assume hii beam yetu ni 5 meters. I will enter. Then of course after ku enter the element, you'll have to enter the support. So I'll just enter the support pinned. Utaweka hapa hivi pinned support. After you enter the pinned support, the next thing is now for you to enter your loads. Ndatumia distributed load na ndatumia 67 kwa sababu iko hapo nda ya haraka tu, from here to here. Now ukirun analysis of this beam, utaona kitu cha kwanza inakupatia the reactions. So this reaction hii ndio nimekuwa najaribu kuwaeleza ndio tuelewe venye nafanya. Na tunajua kwamba from kuna huyu jamaa anaitwa, I don't know, Hooke's law. Hooke's akona, is it Hooke's law? Yeah. We have 3 principles or 3 laws of this guy. I don't know, yeah, ni Hooke's law. Is it? Hii inasema action and reaction, the third law. Yeah. Kuna first law, second law and the third law. Now for the first law sitaipitia, second law sitaipitia, but the third law ndio ile inasema ya kwamba for every action there is an equal and opposite reaction. So utapata ya kwamba if this one is your action, then we must have a reaction, so that when you design your footings, for example this one, for you to design this footing or the foundation, ni lazima tupate all the forces zenye zinakuja chini, so that we design something that can resist all these forces. So hapo hivi tutatumia the third law of that guy yenye nasema for every action there is an equal and opposite reaction. Now, ni kwa sababu gani nimekuja hapa? If this one is your beam and this is now the column, because tukiweka hapa support inamaanisha tumeweka column, then this is now the reaction. This means this column will have to resist, to take care of this load, so that when we come to this one, so this is the reaction, for example 168 kilonewton. So lazima hii column ikuwe in position to resist this reaction, because hii ndio iko inakuja kwa hii column. Then apart from this, ni lazima pia ujifunze how to get the moments, the column moments. Kuna M1 na M2. M1, this is the larger moment, then M2 is the smaller moment, irrespective of the position, kwa sababu hii inaweza geuka ikuwe M2 na hii ikuwe M1. So just to know, M1 is the larger moment, then M2 is the smaller moment, irrespective of the position. It can be at the top or at the bottom. But remember, we have the point load, the axial load acting on top of the column. This is now from the beams, the columns, and the slabs and the walls coming to this column. Then we also have the moments. That's why mutafunza how to design structures against wind, then against earthquake. With me, I think tukikuwa pamoja, I will show you that tutafanya manual kidogo, muelewe venye tunaifanya, and then tutaenda kwa software like Prota and ETABS, then we will use them now to perform that. After hizi loads tumezipata, now zitakuja kwa foundation. Hapa sasa ndio una design the pad footing, or combined footing, or mat foundation, or we have also to design strip, or we also have to design the piles or caissons. So hizo vitu zote ni lazima as a structural engineer, because if pad footing fails, you have to design combined footing. And when we come to this Excel, so assuming that tumeelewana how to design the columns, of course nimeeleza tunakuja ku design pad footing. So for the pad footing, we will discuss this, of course, but all these calculations are okay according to Eurocode and BS 110, and you can also select and print them to PDF and take them to your client or so. Pad footing if fail, you have to design what? Combined footing. And when you come to this Excel, of course, it has given you the option of designing the combined footing. You just have to enter the loads. As I said, we have the point load acting on top of the columns. Apart from this, we also have the moments and so on. So after that, after designing the foundation, now the last thing, as I said, hapa kwa hii model yetu, this one hatujaweka nini, hatujaweka staircase. If I can just open my AutoCAD, because naona muda wetu ni kama unaisha. If I can just open AutoCAD, then come here. Now tujifunze how to design staircase. So tuna manual design of the staircase. As you can see, these are the calculations, the manual calculations zenyewe kabisa. These calculations you can print them and you can also use them. So kazi yako ni kuensure tu ya kwamba all the checks and designs zinapita. Kama hapa inakwambia provide diameter 12 at 200 millimeters. Hapa pia nakwambia provide diameter 12 na zote zimepita, but tumeona red hapa hivi kuna a fail. So for this fail you have to look at the ways. So utajuaje kufanya the manual arrive to eliminate this fail? Ni lazima ujue where you are coming from, these manual calculations, ujue how to do them, how to do all these manual calculations, because mimi nikiangalia this one is failing as per the deflection, span effective depth ratio. So how do we ensure that inapita? We can just increase this one to, for example, 175. Let's try 175. Tukiteremka huku chini utakuja kuona hakuna red pahali, ishatoka. Ndio hii imepita. Design pass the deflection check. But if I take back to 150 millimeters, then itaanguka. So inatakana tupitie hizi vitu zote manually vizuri, muelewe venye hizi formula, kwa sababu hizi ndio vitu mnasoma saa hizi. But now the problem with the universities or the college, amuingi deep sana, so it will be so difficult for you to understand the code. But now when you come to the field, kama haukuelewa vizuri, then itakuwa ngumu kidogo. As I wind up, I wanted to show you this. So tunaweza sema hii ndio model yetu. Let me reduce this one, control 1. Control 1. I want to reduce this one to 0.8. Yeah. Then match properties. So ukiangalia, for example, this is our model. Hii hapa hivi ni slab. This one is just the center line of the or the grid lines. I think mmekutana na vitu kama hizi. Then hizi ni beams zetu, then in slab. So utaanza na kudesign slab, then uchukue hii slab ilete loads zake kwa beams. Then ukishaleta loads zake kwa beam, the beam will now take the loads to the column. So kuna column hapa, kuna another column, kuna another column, kuna another column, kuna another column, like that. So after taking the loads to the column, you now design the columns, and these columns will now take the loads to the foundation cumulatively. Ukiangalia kwa hii Excel, acha niwaonyeshe kitu tunamaanisha cumulatively. Kama hapa hivi, ukiangalia now the cumulative load, utapata the top column, this one, hii column ya juu, hii hapa, hii column ya juu hii iko na load kidogo kwa sababu haipati uzito mwingi, lakini tukikuja kwa hii column ya pili inapata uzito wake kutoka kwa hii floor, this floor, then another load from this floor. Tukikuja kwa hii column uzito unazidi. So kufika kwa foundation huku chini utapata load imecumulate, like it's accumulating. So for the top column the load is just 330 kilonewtons, then inaongezeka to 800, itaongezeka to 13, then itaongezeka to 1882. So hii load itaenda kwa kutumika ku design foundation. Tukikuja hapa hivi ndio waonyesha vitu mambo mengi. Now utapata, now this is the load 335, 841, 13, then 1860. So this load, as we said, action and reaction must be equal and opposite. So for this action, because column ndio imekaa kwa soil, for this action, this is now the action load acting on the ground. This load has to be resisted to avoid settlement and failure of the structure. How do we resist this load? So you have to design the pad. So this 1816.48 itakuja hapa hivi, as you can see 1816.48. Then tunajaribu ku design foundation yenye itafanya nini, ita resist this load. As you can see hapa hivi imefail, this one imefail. So you just have to increase this one. We can use 2.5 for example. Sorry, tunaweza jaribu kutumia 2.5 tuone kama itapita. So as you can see 2.5 imepita, design zote zimepita, but reinforcements, the reinforcement hapa zimefail. So unakuja kwa hii table hapa chini, it's just a guiding table. This one is just a guiding table. Ukiangalia we cannot use T10 because zote zimefail. T12 zote zimefail. We can use T16 at 125. So tutaenda tu hapa hivi, then we will just change T16, then we will change the spacing to 125, alafu tuone. So ukiangalia kila kitu kimepita, but now you have to be very careful. Punching shear kwa foundation, punching shear is very important. As you can see here, punching shear will not occur and the height h is adequate. So all these calculations zimepita, you can print out. So ukienda kwa detailing, you just use 21 T16 at 125 and that is all. Unakuja tunafanya your detailing. Now all these calculations here ni manual calculation. We can use prota structure to do that. Prota can do all things zenye tumeongea, zenye tumediscuss zote. Prota structure can do all that within 2 hours. Unaweza kuwa umefanya everything, so long as you understand how prota does that. Unafanya everything, then you export them to AutoCAD for printing. You can also use Midas. Midas is a complex software. Hii inafanya both low rise, medium rise and high rise building, because as I said, ETABS and Midas were used for design of the tallest building on earth, Burj Khalifa in Dubai. ETABS and Midas, these two softwares were used to do that task. So kama unataka kujua the two softwares, I'm here, I'm available. You can just reach out to me and we can discuss this, and at the end of the day mutakuwa mmeelewa how to use this. But Vincent had requested me to teach him how to use prota structure. Of course, as I said, in 1 week's time, kama uko interested, in 1 week utakuwa umejua how to use this software. Now and any other software. This Excel is available. You can just request me to share with me. But now the problem is at a small fee. But I understand you guys ni wanafunzi, so we can negotiate out, halafu mpate Excel. And as I said, it's a good Excel, especially kama si lazima unitafute mimi nikufunze. Unaweza tumia tu hii Excel, mimi nikukuonyesha tu kidogo, because all these green values, these values zenye mnaona, the cells that are in green color, hizi ni lazima uzichange, but hizi zingine ni formulas, you can't change them. But hizi green lazima uangalie, na ukiklik moja imekupatia guide, like imekwambia what to do. Ukikuja hapa hivi, for example hapa hii imekwambia you have to obtain this value from BS6399 part 1. This one is live load. When you go to that BS, you'll just read the BS kidogo to table 1, then it will give you the loads. Then how do we get the thickness of the slab? You'll read through this, you just place your cursor here, then you'll come here, unasoma kidogo na inakwambia cha kufanya. Ukikuja hapa hivi, for example hapa, you'll go to this clause. In clause kwa BS 110, you go to this clause, you read more about this. Like nyinyi ni wanafunzi, you are not in any rush. You just have to take your time. At the end of the day, ukikuja hapa hivi kwa hizi calculation utakuwa umejua kupenye, utajua ya kwamba table fulani inanipatia area, the minimum area. When you go to this clause, you'll get the maximum area. When you go to clause 3, 12, 11, 1, you'll get the minimum spacing. Na zote zimesha kufanyia. So ni kuconfirm tu na kukubaliana ya kwamba Excel imekupatia the right calculation. Now you can be able to on the Excel. When you come to BIM, as I said, ni wewe tu ujue how to perform the moment distribution method. Otherwise, everything is perfect. So with that being said, I think I can just get some questions from you guys. You can use Kiswahili, you can use English. Mimi si mzuri sana kwa Kiswahili, lakini we can do that. Then kuna hii online platform, niliita the Strian. As you can see, imetupatia the reactions. If you want to see the moments and the shear force, you come here to settings, this one, you click settings. Then ukisha click settings like that, we have now the moments and so on. We have the moments, shear force, the nodal loads, and the deflection. So if you want to see the moments, let me just turn off the loads, the reactions. Unakuja kwa hii the something like an eye. I'll just turn off the reactions and the loads. So when you come here, you can now see the moments. This one is now your moment, 209. 209 is the moment. And also let me check what else. You can also view the reaction, the shear force. This is the shear force. This one is 168 and this one is 167. One of them is positive, another one is negative because of the direction. I think we all understand this. So please, you can use this one also as a learning material. Inatumika kwa field. Sisi tunaitumia sana kwa ofisi. Kama engineer anataka kuangalia kitu haraka, for example, anataka kuangalia kama umedesign hiyo BIM vizuri, anakuja tu hapa hivi. Remember we have the wifi in our offices. Anakuja hapa haraka, then ana confirm, anaangalia moment, then anatumia moment haraka to perform the design, then anakubaliana na everything. So you can actually be using this platform to check your calculation, your hand calculations kama ziko sawa. Hii platform is good. You can also do the how do you call it? Pia unaweza kuja ukaweka hapa hivi nini inaitwaje? Hiyo nini yenu the truss. Unaweza kuja ukachora hapa truss vizuri. You just have to take your time. Unachora your truss, then after that unafanya nini? Unaweka loads, the nodal loads. After that una perform your analysis, you just run the analysis. After running the analysis, itakupatia the moments and everything. Then after that utakuwa sawa. Now, I want to take questions from you guys. Nitaanza na Innocent Tesha. Innocent. Innocent, are you here? Yes. Innocent, atukupati. Teba, unampata Innocent? Hello?
Unaniona?
Yes, nakusikia. Yeah.
Nilikuwa nasema
Yes,
yani
yes.
tunaweza tukachukua kama duration ya muda gani, kwa sababu wiki ijayo
Yes.
tunafungua chuo. Sasa sijajua sana kama watu watapatikana.
I think venye nilikuwa nimesema kusoma prota structure, remember hatuwezi tukasoma prota structure unless una understand penye tunatoka, na penye tunatoka ni the hand calculation, at least uelewe venye hizi vitu zinafanywa, so that tukienda kwa prota unaelewa. Lakini muda wenye mimi naweza nikawapatia kama ni kusoma prota structure ni siku 3, then utakuwa umeelewa prota structure in and out.
Then kuna swala uliongelea hapo kuhusiana na negotiation na hiyo workbook yako ya Excel ambayo hiyo workbook ya Excel ambayo ni macros enabled.
Yes.
Sijajua wewe umeamua labda kunani kiasi gani ili watu wafahamu kwamba kwa ambaye ana mudu kuinunua kwamba achukue, yani ajiandae kwa kiasi gani, au labda watu kama mimi darasa tunaweza tukaunganisha wote tukaweza kuchukua.
Hii workbook venye nilisema tunaitumia, inatumika kwa field, mostly inatumika kwa field. Pia venye mmeona inaweza tumika for learning purposes. I think hiyo tushaona wote. So engineers wenye wako kwa field niko nawauzia at $130. $130, that is approximately, you can convert from your side to Tanzanian money uone ni how much, but kwa sisi ambao ni wanafunzi, naelewa sisi ni wanafunzi pia, nimekuwa hapo juzi tu, si kitambo. We can negotiate na tuone, kwa sababu sisi wote tunataka tusome, na tukikuja kwa engineering hatuna ile kitu ambayo tunaita wivu, kwamba wacha mimi ni, unaona mtu kama we Innocent, tukikuja kwa ukweli ungesema mimi nimepata mwenye anaweza nisaidia, wacha Jacob anisaidie mimi nijue nikuwe sawa, unaona. Lakini you went ahead, you picked a step na ukasema let me involve my class. So hiyo inaonyeshana ya kwamba pia uko na utu kwa watu wenye unakaa nao, unataka pia wajue kitu. So naweza sema hivi, kwa sababu kwa kazi ambayo pia imenigharimu kuicreate haijakuwa rahisi venye tunaweza fikiria, imekuwa kazi ngumu sana. So to negotiate sisi venye tuka hapa hivi Innocent and the 6 of us wenye tuko kwa platform, nikisema $20 workbook nitakuwa nimekosea?
$20.
Yes, $20 niwapatie workbook muitumie, especially for learning purposes. Pia kwa mkiingia field mtaitumia sana na mtaipenda nyinyi peke yenu tu. Is it okay to have $20?
$20 ni reasonable, kwa sababu kwa uwezo wetu tunaweza tukamudu kununua.
Ngoja kidogo, unakatika. Hello, yes Innocent, ni kama unapoteza.
Naam, unasikia?
Yes, nakusikia sasa. Hebu songa karibu na mic kidogo.
Nilikuwa nasema $20 kidogo ni reasonable. Yes. Tunaweza tukamudu kuichukua.
Okay. Yeah, nimereduce tu hivyo kwa sababu remember there is a very smart relationship between sisi wa Kenya na wa Tanzania. And also hakuna mtu mwenye ataki mtu, kila mtu anatakia mtu, kwa sababu kesho hii unaweza pata Innocent wewe, so umesaidia darasa lako, then kwa hilo darasa lako pengine kuna mtu atakusaidia upate kazi, unaona? Ama ni kwa mmoja wenu, kuna mmoja wenu anaweza link Tanzania kwa kwamba Jacob, kuna kazi hapa, tafadhali kuja, unaona? So ni kusaidiana, kesho hii hatujui. So but now the shida ni kwamba, as you saw, Excel is only linked to one computer. Yeah, so the workbook is linked to one computer, and utaipata tu ukishalipa your $20 na kutumia inakusaidia kusoma pia. I'm always available ukitaka pengine kusaidiwa at an individual level. Kama Innocent alikuwa amejitolea kuniuliza maswali, so at an individual level unaweza ni access anytime. Kama leo tumekuwa kwa ofisi, lakini tumekuwa tukiongea na Innocent sana, unanifikia wakati wowote. So I think that's okay.
Sorry, mara
Yes,
moja hivi,
yes.
$20 per person au pa idadi ya watu ambao wanaitaka?
Naweza sema hivi, that's per person because actually okay, si kazi yangu peke yangu ya kwamba mimi ndio naimiliki mimi.
Mm.
Unaona, ukikuja hapa online utapata okay, mimi ndio owner of the work mimi.
Mm.
Lakini ukikuja kwa ili tu maintain hii nini ikuwe online hivi, because ni lazima ikuwe online na lazima hii platform tuilipie. So
Mm.
utapata mimi ndio mwenye workbook of course, lakini kuna watu kadhaa, kama kuna huyu Emily, kuna huyu Mburu, kuna huyu Salim akotoa hapa hivi, I think Salim ako Arusha saa hizi, then
Mm.
kuna Ana Muganda, then kuna Clement Kitum. So hawa ni watu wengi ambao tunajaribu kuona how we can maintain this workbook to be online, to be accessed by most of us. So hii $20 ilikuwa per computer, if I can put it, so per person.
Mm. Aha.
Is that okay with us? Because it's a matter of negotiating.
Of course ni 50,000.
Okay, kidogo
Mm.
Innocent.
Naam.
Kuna Sahid Bahem.
Mm.
Said, unasema aje? Is $20 okay with us? Considering the fact that I think Saidi amekuja saa hizi, acha nimuulize Eric Albert.
Hello,
Eric,
Eric.
yes.
Halo, halo,
Hello, nakupata Eric, tunakupata.
$20. Hapana, still not affordable.
Uh, Innocent. Innocent. Hello. Teba.
Hello,
Yes, yes, yeah, nakupata sasa.
Saidi hapa nilikuwa nimekusikia kama sijakusikia vibaya, ulikuwa unasema ni $20 per computer, not per person, isn't?
Yes, yeah.
So it's me. I think actually it could be affordable if it's per computer, because I was late to join here, but in purpose of learning, maybe per computer, maybe 3 to 2 people they can share to
Yeah,
gain
yeah.
the knowledge. I
I
think
think
it's
that's
affordable.
that's okay, yeah. That's very true.
'Cause I don't know to other people how they are going to contribute on in such kind.
I think
I
chenye naweza nikawa advice pengine at now,
yeah
because nyinyi sasa mmekuja kama group. Hebu
yeah
jaribu mkae chini. Naona Teba amereply kwamba it's not affordable for her. Mkae chini mconclude, muone price ambayo inawafavor nyinyi, kwa sababu mimi sitaki nifanye ni kama natafuta pesa, unaona.
yeah
Sitaki niilete ni kama nimetoka Kenya na kuja Tanzania kutafuta pesa, hapana. This is it's something that is just there for us to, it's created by me. Hakuna mtu atiji pengine kuna mtu fulani ameicreate so najaribu kumuuzia, ni mimi,
yeah
unaona. Hata naweza nikawapatia bure, lakini it's just a matter of appreciating the amount of work yenye time work and everything yenye nimeweka kwa hii workbook, ili ikuje ionekane ya kwamba ipo, then mu access. Sini sawa sawa. So
so,
yeah, mkaeni chini mdiscuss, wenye wataona wanaweza afford, mnaweza chukua hata watu 3 4 muiweke kwa kompyuta moja, then muitumie kuisoma. Penye mnapata pengine mnataka more explanation how to use it or how to get clarification according to BS 81 code, then you can easily reach out to me. Sawa sawa.
okay
Yeah, so mdiscuss, then through Innocent you can reach out to me. Then Teba, I think nimeona reply ya kwamba for you it's not affordable. Yeah, I understand. Yeah, it can be unaffordable, lakini now look at this way. You are an engineer. Remember, engineering is a good paying course. Ukishaimaliza unapata pesa mzuri hapa nje, but now it is going to be so difficult for us to earn this money because tunataka knowledge. Hapa nje ni knowledge inahitajika. Ukikuwa na knowledge ya kwamba you can design, unaweza fanya design, unaweza fanya analysis, that is how you stand out as an individual, ugain ukwe marketable. So Teba, you can discuss with your group, but ukione imeshindikana kabisa, get my contacts from Innocent, alafu tuone venye tunaweza kusaidia. I think that's okay for today. Sawa sawa. Good. Now, Innocent, I think we can just call Innocent to be the host of the meeting. Ndakuomba tufungie hapo, discuss with your group members, alafu mtanipatia the way forward. Kama unatamani kulearn the software, I shared the link with Innocent. You can get the software from that link. Just go and download, alafu unaweza isoma through YouTube, but pia ukitaka kuisoma through me, you can easily access me. Sawa sawa. Yeah.
Sawa. Pia nilikuwa naomba nikumbushe kwamba kuna ile group lako la Telegram.
Yes.
Kama watu